Hi, Grace. So today before our benchmark, we're going to be reviewing rational numbers and square roots. So for the first question, it says circle all of the following that are rational numbers. A, is pi over 4 a rational number? Yes. So highlight it. Or sorry, no it's not because it has pi. Even though it's written as a fraction, it is not a rational number because it has pi. Anything with pi is irrational. For B, we have 9/10. Is B rational? Yep. For C, we have the square root of 81, which is just 9, so that's rational. D, which would continue on forever, that ... means continue on forever without repeating. Is that rational? No, it's not. What about E, square root of 17? I'll underline the ones that are rational so that it's easier to see. Square root of 17 is not a perfect square, so it would not be rational. And lastly, F is a repeating decimal, so it can be written as a fraction. So the answers are B, C, and F. What is a rational number? A rational number is a number that can be written as a fraction. So this includes repeating decimals, terminating decimals, perfect square roots, and all of that. This can also be written as or a number that can be written as an integer divided by another integer, as two integers divided by each other. Okay, so that's letter number 1. Number 2 is asking where the square root of 39 falls on the number line, which point best represents it. So in order to figure this out, I don't even want to look at the number line yet. I want to create our own number line and estimate where the square root of 39 falls. The square root of 39 will be between what two numbers? Yeah, it'll be between 6 and 7, because 6 is the square root of what? 36. And then 7 is the square root of what number? 49. So then where is the square root of 39 going to fall on this number line? How far is it away from 49? It's plus 10 away from 49. And then it's plus 3 away from 36. So is it going to be closer to 49 or to 36? It's going to be a lot closer to 36. So it'll fall somewhere right around here. So now make an estimate for that, and then let's look back at our original problem. So on our original problem, it was asking which point best represents it. So point A is right next to 6, so it's on 6. That would be the square root of what number? The square root of 36, so it's not point A. But we know that it should be pretty close to 6, so which other point is pretty close to 6? The correct answer is point B. For number 3, find the square root of 12 rounded to the nearest tenth. We're doing the same thing. So we're finding the square root of 12. Once I can switch the screen. Okay, so we're doing the square root of 12, which will be between what two numbers? It'll be between 3, because 3 is the square root of 9. And it'll be between 3 and 4, because 4 is the square root of 16. And then where is it going to fall on this number line? Is it going to fall closer to 3 or closer to 4? So 12 is 3 away from 9 and 4 away from 16. So it's going to fall closer to which number? It's going to fall a little bit closer to 3, but it's still pretty close to the middle. So it'll probably fall somewhere. If this was the middle, it would fall like right around here. Okay, so going back to the original problem, our answer choices are, once I can get back to this page, our answer choices are 7.3, 7.5, 7.7, and 7.9. So which one do we think is the closest? 7.3 is probably going to be our best guess. Why don't we look it up quickly just to double check? So if I Google the square root of 9, it's not letting me switch screens, but the square root of 9 the square root of 12 is going to be, perfect, 7.3. So 7.3 is our closest answer. All right, now for our last one, we have circle all of the following that are rational numbers. Again, if it is a repeated decimal rational, yeah, because it can be written as a fraction. As a bonus, how could I write this as a fraction? It would be 23 divided by 99. What about this number continued? No, that would not be rational. What about the square root of 17? No. 5 pi? No. 0.7121? Yes, that is rational. All right, for the exponent review, when you raise an exponent to another power, what do? You want to multiply. So this would be 5 to the 12th power. I'm just going to draw a caret to save time. For this one, when you're multiplying with the same base, what do? You add the exponents. So this will be 2 to what power? 2 to the 7th power. All right, then for this one right here, this should be a b. You have a to the 5th power times b to the 5th power over a to the 3rd power. Here you have two different variables. Can I combine two different terms with different bases? Because I have an a and a b. No, but I do have an a on top and an a on bottom, so I can combine those. If I do 5 minus 3, I'll get a squared. Is that going to be on the top or on the bottom of my fraction? I'll end up with a squared. It's going to be on the top. And then this just becomes 1 on the bottom. Then I have b to the 5th power. Can I do anything with that b to the 5th power? No. So I just end up with a squared times b to the 5th. You can get rid of that 1 if you want. Going back to the third exponent problem, I wanted to skip so I could use a backboard. When I'm dividing with the same base, what can I do to the exponents? I can subtract them. So I'll have 2 minus -5. When you have a division that includes, this would be 3 to the 2 minus -5. When you have division that includes negative exponents, I want you guys to write it out like I'm doing here, and then solve it. If you get a calculator on tests, definitely plug this into the calculator just to be safe. 2 minus -5. Because we're making a lot of little errors with our negatives. This will be 3 to the 7th power. All right, and then looking at the second to last one, I have 3 squared over 3 to the 5th. Again, we're dividing, so I can do 3 to the 2 minus 5. 2 minus 5 is going to be what? Write it as 2 plus -5. It's very hard to write on this. And this will be 3 to the -3rd power. A negative exponent means you write it as what? It means you write it as a fraction. So this is 1 over 3 to the 3rd power. Because negative means the opposite, which means you're doing multiplication or division instead of multiplication. So it's 1 over 3 cubed. Looking back at our answer choices, which of the following is equal to 1 over 3 cubed? 3 cubed is 27, so B is correct, or A is correct, B is correct, C is not correct. And then if you add these together, you'll get 3 to the -3rd, so D is correct as well. So the answers are A, B, and D. Go ahead and try the last one on your